Let's look at some explicit radian examples. We've got a wheel. Let's say it's like a big, well, a small Ferris wheel or some sort of amusement park ride with radius is 5 meters, about 16 feet, and it rotates 2 radians. How far does a person on the edge travel? Okay. Well, first of all, let's get a somewhat accurate picture of this. And so let's remember what radians are vaguely. Remember that one rotation all the way around a circle is 2 pi radians. Super, super important to remember. And half a revolution around half the circle is pi radians. That's bigger than 2, so we're not quite up to that. But a quarter of a revolution is pi over 2, or about 1.5 radians. And so it's in between the 3-ish and the 1.5-ish here. Okay, so it's going to be something like this. This is the picture we've got. And already we can see it certainly looks bigger than the 5, but it's not ridiculously bigger than the 5. Okay, so we want to be able to have pictures of this, but that was actually the hard part. The easy part here is that what's the idea of a radian? It's just a unit of measure, a temporary unit of measure, you can think of it, that's equal to 1 radius. You can just delete that and say it rotates 2 radiuses. Like in the intro video, I talked about how people find it natural to measure things in terms of circumference. We're just measuring it in terms of units of radius. Okay, but we know the radius, so we're done. The arc length traveled, remember S is the letter we typically use for the arc length around the edge of a circle, is just going to be 2 of those units, and those units are 5 meters, and you get 10 meters. That's usually written as S is r theta, if theta is measured in units of radiuses, or in other words, radians. Another way to think about it, to really explicitly write out that unit conversion, is we could write it out like I would write out unit conversions. 2 radians times the conversion that works for this circle, which is 5 meters, is the same as 1 radian. Whenever you do a unit conversion, you just multiply by a fancy version of the number 1, which is this, for this circle, and the radians cancel, and you get 10 meters. Okay, that's a way to think about this very simple equation, S equals r theta. And this equation only works if you measure theta in this unit, so you have to measure it in terms of radiuses, or in other words, radians. Okay, if you could totally develop mathematics in terms of circumferentians, and in some ways it'd be more natural, but there's ways, especially when you get to calculus, it really rocks to use radians. Until then, it's actually not it's not a killer thing to do. So what about a backwards problem? Suppose you have a wheel of radius equal to like 20 centimeters, rather smaller, and I don't want to walk. How about a bug walks? It's pretty small to be walking around. A bug, though, could walk around the edge of this circle, and let's say the bug walks 70 centimeters around the edge. What angle does this subtend? That's the technical term. What angle does that correspond to? Okay, well, 70, okay, if this is 20, freehand 70, it's something like, I don't know, here? Well, let's figure it out, and then we'll maybe redo the picture. Okay, but it's really quite easy. We just convert that to radiuses. 70 centimeters is 70 centimeters times, well, let's see, 1 radian, again, is 1 radius. Cancel out, you get 3.5 radians. If you don't want to see it as a unit conversion and you want to see it more algebraic, you'd say S equals r theta. S is a known quantity. R is a known quantity. Theta is a mystery. But that means theta is just the ratio of those guys, 3.5. And it's measured in terms of radians, in terms of radiuses, which are radians, and so you got it. Okay, that's a little bit bigger than pi, so we can change our picture just a little bit more than half a circle. Okay, so those are a couple of examples. And so those were using S equals r theta. What about converting radians between radians and degrees? So there we were sort of converting between radians and radiuses for a certain circle. Radians to degrees, now that's something where we're measuring just 2 different kinds of measures of angle. It doesn't matter what the radius is for these kinds of problems. So let's say I've got, let me do 2 with slightly different flavor. 2 pi over 3 radians. It's written with a pi in it. That doesn't mean it's a special kind of number. It just means that it happens to be a very simple multiple of pi. It's likely to be something that's simple in terms of revolutions and in terms of degrees. Okay, so 2 pi over 3 radians. Okay, well, let me actually convert it to revolutions as well. 2 pi radians would be exactly 1. That's 1/3 of a revolution. I talked about that in the other video. Okay, how much in terms of degrees? Okay, you can actually do it this way as a two-stage conversion. Okay, and if you just remember that that's 360, you get 120. Oops, getting kind of sloppy. 120 degrees. The slightly faster way is not go do it as a two-stage, and just remember 2 pi over 3 radians. Just do it as a unit conversion, and we know that you could do it as 360 degrees is 2 pi radians. Usually it's a slightly prettier, and this one is actually not any prettier, but usually there's a cancel factor of 2 that's you can just kind of cancel out there. Okay, pi's cancel. 2/3 times 180 degrees is 120 degrees again. Okay, let me go the other way and also do it in terms of something that's not as pretty. Let's say if you have an angle that's 55 degrees. Okay, here's a circle, part of a circle. 55 is bigger than 45, so something like this. So I take a wedge of pizza, let's say, that's about 55 degrees at the vertex there. How much crust, as measured in units of the radius, are you getting? So what is this theta in terms of radians? Okay, so again, it's just a unit conversion. But here it's not going to come out nice. In the other example, it was relatively pretty in radians. It had to have a pi in it to make it look pretty. And it was definitely nice in terms of degrees. This is just going to be, okay, now to convert it, we need the 180 degrees on the bottom and the pi radians on the top. Sometimes you can abbreviate it with rad, that's okay. And often you don't even have to put it at all, because if you don't put anything at all, it's assumed that radians is your unit, because it is the most privileged unit. And so this is just going to be 55 over 180 times pi. Oh, I should have prepared that. It's going to be about, very, very roughly, it's going to be about 0.8 radians. And if you want to prove me wrong, if that's not good to one decimal place, well, let me know. I'm just trying to do it in my head. Okay? But you just have to do that calculation. So that's going to be, this is our universal conversion. Pi radians over 180 or 180 degrees over pi if you're converting back and forth. Okay.